Welcome to another session of highway engineering. In the last few classes, we were discussing about the design aspects of horizontal alignment. So we spoke about design speed, we spoke about super elevation and its other aspects. So this session, we are going to talk about another geometrical aspect, which is something called as radius of curvature R. So before we start with, let me give you a clear picture of what is radius of curvature. When we say radius of a curve, what is that it meant on a horizontal curve? So this is typically a horizontal curve. So we know that there is a straight section and slowly you need to bring in the change in direction. So that is something called as a transition curve. And after the transition curve, you will be introducing the circular curve, and at the same exit after your circular curve, slowly again change in the direction, which is achieved by introducing the transition curve and followed by the straight section. So this is typically a horizontal curve will look like. Now what is radius of curvature here? So if I consider the circular curve, so you can please recall an arc of a circle concept if you are taking in. So if this is my circular curve, which I am considering as an arc, and if I am going to construct a circle over here, and one can take the center point from there to this arc, this is what is called as the radius of curvature R. So this is what the meaning of radius of curvature. Okay, now what is that we are interested in the design aspect? How much is the R value? What is the R value one has to set when you are planning to design your highway, especially on the horizontal curve? This is what the point of discussion in today's session. So among all the geometric parameters we discussed, we said the most important parameter as design speed, because generally the horizontal curve of the highway is designed for considering this design speed. Now under the design speed, we said the guiding criteria is something called as the ruling design speed. So wherever possible, attempt should be made to design all the other parameters to meet the design speed. That design speed will be named as ruling design speed. Now if there is any constraint or the other economic considerations are there, there is unable to provide this ruling design speed, one can think of providing a minimum design speed. So generally the highway will be designed for this particular design speed, ruling design speed. To make it more clear, we have even seen like what is the IRC suggestions for the various speeds for different classes of the road under different terrain conditions. For if you take an example of NH and SH, national highways, the ruling design speed is recommended as 100 km per hour. Wherever if one is unable to design their curvature for this 100, wherever if it is not possible to design your highway for this 100 km per hour, then the minimum value as specified as 80 km per hour. This is the meaning. Correct. Now let's see, with once the design speed is set, how to discuss about the how to set for the radius of curvature. So we all know that when a vehicle traverses a curve, there develops the centrifugal force, and the aim is to limit the centrifugal ratio. So P by W, the centrifugal ratio, if you write the equation, V square by GR. Now for a chosen speed, it can be either ruling speed or the minimum speed. Okay, so let's consider this the ruling design speed. So it can be anything. Okay, so let's consider that for a chosen design speed, what is the centrifugal ratio is going to depend on? It's going to depend on the R value. So if I have to limit this P by W, what should be the value of R? R should be significantly high. Are we in a position to give a flat radius, a flat curve which is having a quite a high value of radius? This is what the question which arises. Okay, so let's see how to design, design or decide about what is the R value to be taken. Now how will I derive an equation for R, or how will I calculate R? So we have written the equation P by W is equal to V square by GR. And I know that this V square by GR is counteracted by what? by providing super elevation and also by the lateral coefficient of friction. The lateral friction will support or counteract this centrifugal force. Okay, so E is nothing but super elevation, and you know the maximum value as 7%, 0.07 in plain terrain, and F is for the design purpose, one is considering 0.15. V is nothing but your design speed. It can be ruling, it can be minimum design speed. That should be something there in your mind. Now, if I'm asking you to like tell me how to calculate R, very simple from this equation. R is equal to V square by G into E plus F. Right? I can get the value of R. So here V is in meter per second. Now somebody wants to write in kilometer per hour. We can write V square divided by 127 E plus F. This is in converted in kilometer per hour. So for your better understanding, I can write meter per second here, and this is in kilometer per hour. Now, when we said about the design speed, chosen design speed, which is your chosen design speed, it can be a ruling value or it can be the minimum value. So let's derive the conditions according to that. If the R value, I'm just taking the kilometer per hour, V square divided by 127 E plus F, if I'm taking, and I'm saying this speed is the ruling design speed. So I'm going to write ruling design speed. Then the R value provided is called as the ruling minimum radius. Ruling minimum radius. So you will be calculating the value of R according to the chosen ruling design speed. To make it much more clear, let's take the example. What did I say? I said for national highways and state highways, the ruling design speed is taken as 100 km per hour. So I'm going to quickly substitute that. R is equal to 100 square divided by 127. E is 0.07 plus F is 0.15. In that case, you may get a value close to 357. Approximate it as 360. R is always in meter. 360 meter. One need to provide 360 meter as minimum. So that's why it is called as a ruling minimum radius. Minimum provided should be 360 meter. This is the meaning over there. Okay. Now, in a similar manner, if instead of taking this ruling design speed, if I am considering it as the minimum, because I am not in a position to provide the ruling. So I am just taking the minimum design speed. Then R value is called as absolute minimum. Absolute minimum radius of curvature. Okay, absolute minimum radius. So the same way, let's take the example for national highways. 80 is considered as the minimum design speed. So if you are designing R value according to that, 80 square divided by 127 into 0.07 plus 0.15. This will give you a value close to 230 meter. Okay, so this is the meaning. Whatever, please understand this point. The most crucial parameter is the design speed. The highway is going to design based on the chosen design speed. Once the design speed is fixed, the other parameters, in this case the design speed, the radius of curvature has to be derived or calculated based on the chosen design speed. Now, I have two criteria here. I can either design for the ruling value, ruling design speed, which is considered as a guiding criteria. Then the R value which I will get is called as the ruling minimum. So whatever, in this case you are getting 360 minimum, that value you need to be provided according to the area. If you have more, you can provide a larger turning radius also. Now, the second case, whenever ruling value is not able to adopt, if you are adopting a minimum design speed, calculate the R value, and that is called as an absolute minimum R value. Okay, so that is also minimum. You can be considered as maximum also. Now I am going to show you a table what is IRC suggested, similar for the design speed. The minimum radius of horizontal curve for different terrain conditions. So one can see similar to what we discussed for the design speed, different terrains, different class of the road. So one can see national highway and state highway. I am just saying ruling minimum is 360, absolute minimum is 230 meter. Please understand, this is minimum value. Okay, this is minimum value, one can provide more than that. So you don't have to by heart this table. In fact, if you know which is the chosen speed, according to that one can calculate the R value. I hope that is clear. Thank you.